Hello, and welcome to the first of several video lessons. We're going to try some video lessons in the weeks that follow as we take up the study of the integral calculus, and I have several reasons for thinking that these are going to be worthwhile. I guess maybe the first reason is you can watch them anytime you need to. Now they will be assigned at a particular time, and I'll expect that you'll watch them, and then when you come to class the next day you will have at least watched the video lesson once or twice, which means that I won't be presenting that material, but you and I together will be working problems using that material. So that'll give us a chance to work together, and when you have questions I'll be in the room to answer questions with you. A second maybe good reason to do video lessons is that you can review and watch as often as necessary. So I'm going to say watch 20 times, though I know nobody will watch these 20 times. You may want to watch them twice, and then before an exam you may want to come back and watch them again. So those are two good reasons, and then I might add a third. Class time can be spent working together. So just to see how the process works and to get us started, we're going to take the next topic in our book, which is the first topic about indefinite integrals, and that's the second big division of the calculus. The first calculus topics that we took up were the derivative of a function f of x with respect to an independent variable, dx. The second topic, we're going to be finding the integral f of x dx. And the thing to keep in mind initially is that we found a process for finding these derivatives. And as a result of studying the process and applying it, we got very good at taking derivatives. Well, there's going to be a process for finding antiderivatives as well. Now, as an example of why we would want to find antiderivatives, I want you to remember a problem that we worked earlier in the semester. In fact, I think it was just last week, where we had a price, and I think it was for a cup of coffee, but it wouldn't really matter what it was for. Price P for, let's say, coffee. And we have X equal to the demand for our coffee. And we know that we've got a price demand function, and we could call that price demand function f of x, and so P is equal to a function of x, but we don't know what that function f of x is. So that's kind of sad. But in these problems that I'm thinking of, we did know something about f of x. We know that if we would decrease the price, I'm going to call that a delta p, by a nickel, negative 0.05, as a result, there'd be a change in the demand for our coffee, and we said that the demand would increase by 50 cups a day or a week or whatever the time interval was. What actually this tells us is that delta y over delta x is equal to negative 0.05 over 50, and that's really the derivative of the price demand function f. So that's f prime x. So, wow, here is a case where we know f prime of x, but we don't know f of x. And what I need to do before I can establish a revenue function, I need to be able to figure out what f of x is. So I'm going to ask the question, what is f of x? Well, I do know this. I know that f of x is a function that has this property, that has the property d f of x dx is equal to negative 0.05 over 50. I know the derivative of f, but I don't know f. The indefinite integral of negative 0.05 over 50 dx, and this is a notation. This is the integral sign in elongated s. The integral sign of, this is called the integrand, the negative 0.05 over 50, and the dx tells me that I want the integral with respect to the variable x. So that's a symbol for a function whose derivative is the integrand, negative 0.05 over 50. So we will have a process for finding out what that integral is. And before I show you the process, I will tell you right now that this will turn out to be negative 0.05 over 50 x plus a constant. And in fact, the indefinite integral is a whole family of functions, and it's this constant on the end that lets us pick a particular member of that family to solve a particular application problem. So that's what we'll be doing in the next 3 or 4 videos. I hope you like the video lessons. Let me know if there's something I can do to improve them, and I'll see you in the next video.